Today we're going to be speaking about the mole. Have you ever wondered about the mysterious unit of measurement known as the mole? The tiny word holds immense significance in the world of chemistry, yet many people have never heard of it. Today we will unravel the mystery behind the mole and discover why it is so important. At its core, the mole is simply a way to measure the amount of a substance in a given sample. But what makes it so intriguing is the way it allows chemists to understand the fundamental building blocks of matter. With just a few simple calculations, we can determine the number of atoms or molecules present in a sample, a feat that would have been impossible just a few decades ago. So join us on this journey as we explore the fascinating world of the mole. A mole, short for mole, is a unit of measurement used in chemistry to express amounts of chemical substance. It is similar to how we use dozen to represent 12 items. However, a mole represents a much larger quantity, specifically the amount of substance that contains as many elementary entities, such as atoms and molecules, as there are atoms in exactly 12 grams of carbon-12. This may sound complicated, but think of it like this. If you had a big bag of marbles and you wanted to know how many marbles were in it, you would count them one by one, or you could weigh the bag and divide the weight by the weight of one marble. Similarly, using moles allows chemists to measure substances in a more efficient and precise way. The mole, short for mole, is a fundamental unit of measurement in chemistry. It represents a specific number of atoms or molecules which allows scientists to accurately measure and predict chemical reactions. This is especially important in industries such as pharmaceuticals and materials science, where precise measurements can make the difference between success and failure. One real-world example of the importance of the mole is the production of semiconductors. These tiny devices are used in everything from smartphones to spacecraft, and their performance depends on the precise arrangement of atoms within them. By using the mole to measure and control the amount of dopants or impurities added to the semiconductor material, scientists can precisely tune its electrical properties and improve its performance. To calculate a mole, you need to know the mass of the substance in question as well as its molar mass, which is the mass of one mole of that substance. The molar mass can be found on the periodic table by adding up the atomic masses of all the atoms in the molecule. Once you have these values, you can use the formula N equals m over m, where N is the number of moles, m is the mass of the substance, and m is the molar mass. For example, if you have 10 grams of sodium chloride, you would first find the molar mass of NaCl, which is 58.44 grams per mole, then use the formula N equals m over m. You would divide 10 grams by 58.44 to get 0.171 moles of NaCl. This calculation can be used for any substance, whether it is an element or a compound. As we look to the future, the potential for further advancements in the use of the mole is vast and exciting. The ability to accurately measure and manipulate the amounts of substance in a chemical reaction has already led to significant breakthroughs in various industries, from pharmaceuticals to energy production. Current research and development in the field of the mole is focused on improving the precision and accuracy of measurement techniques, as well as exploring new applications for this fundamental unit of measurement. For example, scientists are investigating the use of the mole in the development of new materials with unique properties such as superconductors and self-healing polymers. I hope you guys enjoyed our introduction to the mole today and learned a lot more about the wonderful world of chemistry.